Hello and welcome to the section 5 of the Automated UI Testing in Java video course.
In this section, we'll get introduced to the object-driven approach. It has already been mentioned in the introduction video, but this time we'll dig into more details. During this section, we'll go through major concepts and design of an object-driven framework approach. Then, we'll create an engine for it. After that, we'll implement data transferring mechanism which would be useful in the future. And finally, we'll implement some sample tests to see the approach on practice. So let's start with the first chapter. In this video, we'll mainly describe the concept of the object-driven framework. We'll describe the idea behind the approach. We'll figure out major entities we should operate with and their structure. Also, we'll describe major flow we should implement. Eventually, we'll design the object-driven framework structure before going to actual implementation. As it logically goes from the name of the approach, object-driven approach is based on object. The major idea of it is that all core test entities like test steps, test scenarios, or simply tests, and test suites are represented as objects. Since Java is the programming language supporting object-oriented programming paradigm, this approach is pretty much applicable here, and from time to time people come to this approach intuitively. At least I had a chance to observe such situation on practice several times. Anyway, as it has already been mentioned, the approach operates with three entity types. They are steps, tests, and test suites. All of them are represented as classes. This diagram shows the relationship between those entities. So, the test suite class is the container for test case objects, which in turn are containers for step objects. Also, suite and test have before and after steps, which are also steps objects. All those classes contain run method, which implement common flow. At the same time, there are methods we should override. For example, when we extend step class, we need to override step body method, where we should define actual step actions. Also, we may override some specific handlers like onError method, which should handle cases when error occurs. But that were just entities. The class hierarchy is a bit more complicated, as we should extract common functionality. Here we see the prototype of classes we should create. Thus, the topmost class is ODT_runner class, which run method is available in every subsequent classes. At this level, this method should be abstract, as we have to override this method in extended classes. Also, this class should handle past state as well as define event handlers. Those handlers are to be performed before, after actual run call, as well as there we define onError method, which is to be triggered in case of error. The step class called ODT_step is extended directly from the ODT_runner class. Mainly, we should define abstract step body method. So, when we create custom step object, we need to implement this method and put actions of the step. For the test and suite objects, we can have two dedicated classes named ODT_testCase and ODT_testSuite respectively. Those classes are almost identical, except they are containers for different object types. For example, ODT_testCase class is the container for ODT steps. The suite class, named ODT_testSuite, is the container of ODT_testCase objects. But apart from this, everything else is the same. Thus, it makes sense to create interim generic class which implements common flows. The only generic parameter is the type of contained entities. We'll see that on practice in next videos. We defined the structure of our engine. The only remaining thing is to describe the major flow of steps processing, which is common both for test and suite classes. That should be the content of the run method of those classes. The flow has several stages. When we start execution, we should run steps which are supposed to run before entire test or suite is executed. After that, we'll go through all entities we contain and run them one by one. For the suite, that would be calls for tests. while for test class that would be calls for step objects. For each contained item, we run it and make sure it doesn't fail. So, if item run is successful, we go to the next iteration. After all entities are executed, we invoke steps, which are to be executed after entire test or suite depending on what class we are running. Once all after steps are performed, we end up with the run. Additionally, we should react on failed cases. If we encounter some error, we should break execution loop immediately. Then we should run on error method to handle an exception we caught. After that, we should call after steps. It is important to make sure that after steps are invoked, as we potentially can have some settings done during the test which should be recovered anyway. So, this is how the major flow for tests or steps processing looks like. This is it for the introduction. We've described major idea of object-driven approach in general. We've defined core entities and designed the class hierarchy we should use while implementing engine. Also, we've defined the major flow for processing steps and tests. Now it's time to implement all the above things on practice.